Okay, perfect. Okay, so today's lesson is going to be about data displays. So what data displays are meaningful ways on how to present data, and so it makes sure that you can see your data in a way that's more meaningful. So when you use data representations, you can understand the data better rather than looking at numbers. So you guys can see that pie charts are a good way to look at stuff. Histograms Histograms are a good way to look at stuff, and icons. So the types of things that represent data are a really good way to display your data in meaningful ways. So we'll be going over different types of graphs today. And if you guys have any questions, just interrupt me when I'm talking, or just wait till I ask for questions. Okay, so 10.1, we're going to be learning about stem and leaf plots. So we're going to be learning about how to interpret stem and leaf plots. And stem and leaf plots are essentially one way to look at data. So key terms that you're going to be learning are what stem and leaf plot is. So it uses digits of data values to organize a set of data. So what this stem right here, let me go ahead and explain this, right? So your stem is your tens values, right? So your one distribution in the data would be 20, another distribution would be another 20. And so what this allows you to do is to put all your data together and see the different distributions along the different types of tens. So a stem and leaf plot uses digits of data values to organize a data set. Each data value is broken into a stem. Digits or digit on the left of a number is a leaf. So digit or digits on the right of a number. So this is your data that you have right here, right? So it says make a stem leaf plot of the length of 12 cell phone calls. So first of all, you need to order the data from least to greatest, right? So now choose your stems and your leaves. Because the data values range from 2 to 25, use the tens digits for the stems and the ones digits for the leaves. Be sure to include the key. Do you guys understand how they ordered the data? Or so they ordered it from least to greatest. And so now what they did was they took the stems. So notice that the stems are the 10 values. So when you're representing 10, let's say, right? This is the stem 1, the tens value, and 0. And then you have 14, right? So that's 1, 4, right? 18, 10, and 8. So that's 18. So they organize their data like this. So do you guys understand how leaf and plot data work, or do you want me to go over another example on how you would make it?
No, I think I understand it.
Okay. Okay, so make a stem and leaf plot from each of the data sets right here. Let me go ahead and let me go grab a piece of paper, and if we need, we can go over these together. Let me know once you guys are done, okay?
I'm done.
Okay, so let's go over number 4. Do you want to show us actually just tell me what your page looks like verbally. So describe to me what your stems are and describe to me for each stem what is your leaf.
My stems are 0, 1, 2, 3, and 4. And for the 0, there's 9. And for 1, there's 5, 7, and 9. And for 2, there's 0, 5, 6, and 9. And for 3, there's 1 and 2. And for 4, there's 0.
Okay. Is that all of number 4?
Yeah, there's only
Okay.
1.
Okay, so did you try doing number 5, 6, and 7?
Oh, no.
Okay, go ahead and try doing those. Rima, are you running into any issues or are you okay? Okay. Rima, do you want me to go over a problem with you? Would that help you understand it better? Okay, cool. Okay, so let's go ahead and let me go ahead and share a different screen. Tanmay, can you just wait 1 second while I try to explain this to Rima? I'm gonna share a Jamboard so you guys can see better, understand it better. Give me 1 second. Okay, so this is our this is the data set that we have, right? So first thing that we're gonna do is organize the data in terms of we're gonna organize the data in terms of least to greatest, right? So first we have 9, and then we have 15, 17, 19, and cross off the ones that I've already done.
20?
Yeah, 20,
25?
25,
26?
26,
26?
26,
29?
29,
31 and 32?
31, and 32. Thank you
And
for
40?
helping me out. 40, yes, right. Okay, so now what you want to do is arrange your stems. So the greatest stem that we have is 40, right? Right, so now you have 1, 2, 3, 4, right? And so now, oh wait, you have to start off by 0, remember, because we have 9, right? So now you want to arrange your stem. So 9, 0, 9. So when the number doesn't have a number in between, so it'd be 0 and 9, right? Because it's a single digit number. So you would put 9 right here, right? And then you can cross this off, right? 15 is the least, so we'll put 15. 1, 5 is 15, right? So 1, 5, this would be the stem, this would be the leaf. And so then you can cross this one off. This is 7, right? This is 9. So now we have 20. This is the stem, this is the leaf, right? So we can just put this as 0. 25 is 5. 26 is 6. 26 again is 6.
And then 9?
This, yeah, so then 9. So then 31, right? So then that would be 1. And so then
And then
guess
there's
what
2.
32? Yeah. And now
And
you
then
just,
there's 0 for 4.
yeah. So that's how a stem plot works. Does that make more sense?
Yes.
Okay. Rima, did you understand it better?
Yes.
Okay, perfect. Okay, so let me go ahead and back to the practice problems. And if you need to go over those practice problems, I'll help you guys get through those. Give me 1 second. Okay. Just let me know once you're done, okay? Okay, what are you guys, what problems are you on?
I'm on 3 or 6.
6? Okay. Are you done, Tanmay?
Almost.
Okay. Rima, what about you?
I'm on number 5.
Okay, go
I'm
ahead and
almost
finish
done.
up. Okay, so let me, because we need to go through other things in this lesson. So let's go ahead and share me what you guys have already.
I did 5 and 6.
Okay, so let me just read through the answers and you guys can check because it'll go faster. Okay, so number 5, the stem is 0. So you have 0, 2, 6, and 8. And those would be your leaf. So then your next stem would be 1. So then your leaf would be 2, 2, 4, and 8. Oh, sorry, I missed 5 in between, so it'd be 2, 2, 2, 4, 5, and 7, 8. Sorry. And then your last stem would be 21. So then 2 and 1.
Wait, I thought there's also a 4. 24.
Oh, yeah, I missed 24. Sorry, my bad. Stem is 2, and then your leaf is 1 and 4. My bad. Okay, number 6. So your first stem would be 6. So then 6, 5, 8. So then those would be your leaf. So next stem would be you don't have any squares in the 70, so you'd still have to write 7, but you wouldn't write anything in the 7 leaf, right? So then you would move on to 8, which would be 8 would be, oh, the solutions are here. I don't know. Okay. So yes, I didn't see that we had the solutions, but if you want to just check it right here. My bad. I didn't know. I didn't make the slide deck today, so you guys can check your solutions here. Okay, I'm gonna move on. Okay, so let's start to analyze and interpret what stem and leaf plots are. So how many students got less than 80 points? So go ahead and try to figure that out.
Five students?
Yes. Do you understand why it's 5 students?
Yes.
Perfect.
Yeah.
Who answered that?
Tinmai.
Rima answered it?
No, Tinmai.
Okay. Rima, try to answer B. How many students at least scored 90 points?
4.
4.
4?
Mm-hmm.
Scored at least 90 points. Okay, so yeah, it would be 4. Good job. So here's the solutions. So now we'll be going over histograms. So histograms are another way to analyze data. So key terms when you're using histograms would be frequency table. So a frequency table groups data values into intervals. The frequency is the number of values in an interval. So it looks like this. So let me go ahead and explain this a little bit, right? So let's say you have a class of let's say there's different class sizes, right? Or there's different class sizes, right? So you have a class that can be up to 0 to 39 kids would be this many. 40 to 79 would be 5 classes. 80 to 119 would be 12 classes. 120 to 159 would be 8. And 160 to 199 would be 4. And 200 to 239 would be 1. So the total sum would be 31, right? So that's the total number of classes that there are. So a frequency data basically says that like between these two numbers, this is how many classes there are, or in this scenario at least. Does that make sense?
Yes.
Okay. So now we have a histogram. A histogram is a bar graph that shows the frequency of data values in intervals that are of the same size. The height of the bar represents the number of something, and it looks like this. So you have the different intervals right here. See, so the number of CDs someone owns, right? So 0 to 9. So 0 to 9, 4 people own that many CDs. 10 through 19 CDs, 3 people own that many CDs. 20 to 29.
I don't get the frequency table.
Okay, so frequency table is essentially like you have an interval, right? So instead of looking at this frequency table, let me explain it in terms of this, so it'll make more sense to you, right? So you have 0 through 9 people. Sorry, 0 through 9 people who own CDs. So you see 0 through 9 people right here own CDs. So sorry, my bad. 4 people own 0 to 9 CDs, right? That's the frequency of people that own this many CDs in this interval gap, right? If someone owns 10 to 19 CDs, they end up in this frequency graph, which is 3. And then if they own 20 to 29 CDs, then it is at least one person who does that. So then 30 to 39 CDs, there's at least 2 people who have 30 to 39 CDs. Does that make a little more sense? And so then these tallies, right? These tallies are the number of people, right? So in this case, you would have 4 tallies. This case, you'd have 3, 1, and 2, right? And then you'd add those all up, right? That'd be the total number of people that participated in your experiment or whatever you're trying to do. Does that make sense?
Yes.
I don't
Okay.
know what class interval is on the top.
Okay, so that's for one case scenario. That's for a problem. I think we pulled it off of Google, but basically what an interval allows you to do is to kind of space out your data saying this is how many people have it or this is how many people don't have it. So kind of explain the interval to kind of, it's more or less trying to explain that this is the amount of something that someone has, or this is like what category they all kind of classify under, their averages. Does that make more sense?
Yes.
Oh.
Okay. So key idea. So our frequency table shows the number of laps that people in a swimming pool have completed today. Display the data in a histogram. Okay, so step 1, draw and label the axis. So right, so frequency is the number of laps that they completed, and frequency is the number of people that they have that completed these certain gaps. So include any interval with a frequency of 0, right? The bar height is 0. So 1 to 3, right? That's that frequency of people, the number of people that did 1 to 3 laps was 11, right? So 1 to 3 on the graph right here covers 11 of these bricks. So 11 frequency, that's the frequency of the number of people that did that many laps. 4 to 6 is, again, the frequency is 4. So 4 people did at least 4 did 4 to 6, right? And 7 through 9, nobody did that. So you would still include that interval, but the bar height is 0, right? So there is no space between the bars of a histogram. So that's also important to know, because the intervals are all numbers that are connected together. So moving on, the number of laps that someone's done, 10 to 12, the number of people who have done that is 3, right? The number of laps, 13 through 15, 6 people have done that, right? So you have 6 right here. Does that make sense on how you would make a histogram?
Yes.
Perfect. So
Yeah.
this is an example of a frequency table. Okay, so go ahead and display these datas in a histogram. Let me know once you guys are done.
What do we do after we're done?
Are both of you done? Just let me know once you both are done.
Okay.
Then May, are you done?
Almost.
Okay. Go ahead and finish up. And just let me know once you're done. Okay, I'm gonna go ahead and show the answers. So the first graph shows the number 6, and the second one shows number 7. So was there anyone who ran into any problems or got it wrong?
I'm good. I got
Okay.
them correct for now. I want to say
What?
I got them correct.
Okay, good job.
Is it okay if we drew it differently than that?
How different did you draw it?
So I didn't for the top one. For the number 1, I didn't add the 16. I only put up to 14 because that's all what we needed for the frequency.
Yeah, that's fine.
Oh, and that's the only thing I did.
Typically, when you're given numbers, you just want to make sure you have a couple intervals ahead of that in case you want to add more to your data. But it's fine if you didn't do that. So so you mean you didn't add the 16 up here on the y-axis?
Yes.
Yeah, so it's fine. Um. Okay, I'm gonna move on. Okay, so this histogram shows the number of hours students slept last night. How many students got at least 8 hours of sleep? So Rima or Tanmay, just answer that question.
11 people.
8 plus 3, yes, 11. And who answered that one?
Rima.
Okay, Tanmay, try to answer B. How many students slept less than 12 hours? Is she still here?
18.
Yep, good job. So A is 11 students got less than 8 hours of sleep. 18 students got less than 12 hours of sleep. So good job. So shapes of distribution. So you're going to be learning about how to describe shapes of distribution. So 10.3 will cover symmetric. So the key ideas that we have here are symmetric and skewed distribution. So skewed left means that the tail so the tail right here, this is the this blue line right here is what we call the tail, right? So this tail extends to the left of the graph. Most data are on. How do I put this down? Okay, let me go ahead and exit for a second. Most data are on the right. So then the symmetric. Um, 1 second. So the left side of the graph is a mirror image of the right. So this means that the graph is symmetrical. So if we like folded it in half and flipped it on the other side, it means it's the same, right? So it's a mirror image of the right on the graph. So it's the same on each side. So skewed right means that the tail of the graph extends to the right, right? Most of the data is on the left. So in here, most of the data is on the right, and this one, the data is on the left. So it's just the way of how the tail, which way the tail is pointing. So remember, look at the ends of where each tail are. So that's an easy way to remember what skewed right and skewed left is. So where it ends is a good way to look at it. Or where the peak point is. So the peak point would be closer to the right if it was skewed right, and if it was skewed left, then it would be closer to the right. Does that make sense?
Yes.
Okay, so go ahead and describe each shape of distribution.
So for the first one, it's skewed right.
Mm-hmm.
And then for the second one, it's symmetric.
Yep. Most of the data is on the left, so the tail extends to the right. So the distribution is skewed right. Good job. So now we're gonna learn how to make a dot plot. So you probably already know what a dot plot is, but so go ahead and make a dot plot just to see whether you guys understand it or not. I'll go over it if you guys don't understand it.
I'm done. I did number 3, so should I work on number 4 now?
Yeah, do both problems.
I answered all the problems, so should I show you my line plot or just
Can you can you share your screen, or if you want you can turn on your camera and like put your paper up to the camera and you can show me that way.
can you see it or no?
Let me stop presenting. Give me 1 second. Rima, you have to turn on your camera, I think.
I turned it on. It's not letting me. Yeah, it's not letting me.
Okay, so I can just go ahead and show you the answers on my slide deck, and then you can just check it from there.
So for the first one, it's skewered right, and then the other one is symmetric. Yeah.
Yep, good job. So it's uniform, it's not symmetric. So the problem is, so uniform means that all of the columns are, all of the dots are uniform. So they're all the same height, essentially. So uniform just means that everything's the same, right? Whereas symmetric means it's symmetric on both sides. So if I reflect the image, it's the same, right? So I can see how you would get confused with symmetric and uniform, but just remember uniform means that all the the heights are all the same.
And then for symmetric means if you fold in, if you look at the line plot and it's all symmetric, that means it's symmetric.
Yeah, essentially. So when it's uniform, it means that the height of the columns is all the same, right? So they're all uniform in that way. They're the same, right? Whereas when you look at a symmetric, whereas if you look at symmetric, right, it's not all congruent. Like, you would basically have to make a mirror image of it, and then you would have to say that it's symmetric, right? Symmetric doesn't necessarily mean congruent. So uniform means congruent, right? So the frequency was all the same, right? So that's how you would say that the distribution is uniform. It's all the same.
Okay.
Yeah, I got the same answer.
What?
I got the same answer.
Okay, good job. Okay, so 10.4, box and whisker plots. So today you'll be learning how to interpret box and whisker plots and how to compare box and whisker plots. So what a box and whisker plot represents is a data set along a number line by using the least value, the greatest value, and the quartiles of the data. The box and whisker plot shows the variability of a data set. So your least value is this green dot right here. This green dot right here is the least value in your data set. Your greatest value is is right here, and your median is the number that's right in the middle of all of your data set, right? And then your first quartile comes here, and your third quartile comes here, right? And your median is obviously your second quartile, or it's easier to call it the median, right? So the 5 numbers that make up the box and whisker plot are called the 5-number summary on the data set. Okay, so make a box and whisker plot for the ages and years of the spider monkeys at a zoo, right? So this is the numbers that you have, right? This is the data set, right? And your least value is 14 and your greatest value is right here, right? And you know that your median is 30. So now what you do is take the median of these numbers, right? And your first quartile is 36, which is the number right here. And your third quartile, you take these numbers, right? And the middle is that third quartile right there. Does that make sense?
Yes.
So draw a number line between that includes the greatest and least values. Graph the points above the number that represent the 5-number summary. So your least value is 14.
I don't think that's box and whisker plots.
Okay, which part do you not understand? Is it the part right here? This part? Okay,
No,
let me go ahead.
I don't get why we need the box and whisker and stuff.
Okay, so this is just another way to represent data, right? So as we looked over graphs, right? So this is just another way to show how your data is being distributed and to show like this is the least value that you can have. This is the greatest value, right? This is your first quartile. This is your third quartile, right? So this is on the higher. This is the range in between that you're looking for in this set of data, right? So this range. Does that make a little more sense?
I don't get why the first quartile and the third quartile are in those places. I thought.
Okay, so give me a second. I'm gonna move this to a Jamboard and we can look over it a little more carefully. I understand this might be confusing, so I'll go over it in a little bit in depth. 1 second. Give me 1 minute so that I can move this to a Jamboard and we can explain this a bit better. Okay, so this is our data set, right? So it's already arranged for us from least to greatest, right? Let's go ahead and pull up a pen and use the brush. Okay, so our least value right here. Oh, that's not good. Okay. So our least value that we have right here, that's number 14, right? I don't like this. Give me 1 second. Okay, so our least value is this number right here, right? This is the first dot of our graph, right? So let's go ahead and make the number line right here. Right. This is our number line. Right, so then our greatest value is also 38, right? So now we need to find the median, right? The median is the number that's going to be in the middle. So how do you find the median, right? So when you find the median, you subtract, you take one value from here, right? So take one value, cut one value right here, cut another value, right? And then you should have the median, right? This is the median right here. So this number right here is the median, right? Now it's stuck in between two numbers. So what you want to do is find the middle of these two numbers, right? So 30 plus 30 is 60. 60 divided by 2, which is 30, right? So this number is now 30. So this median is 30, right? So let's put 30 in the middle of our graph. And 14 would be a little bit over here, right? So 14. So 14 is right here. This dot is 14. Let me go ahead and use a different color. This is 14. Yeah, what are you saying?
I have a question. So is this basically like rounding or something?
This is not rounding. It's just another way of displaying your data.
Oh, okay. Thanks.
Okay, so do you want me to finish up with this, or do you think you understand it a little bit better?
So what do you do after you find the median and then you put 14 and 38 on the sides? What do you do after that?
So now you need to find the first quartile and the third quartile, right? So by doing that, what you basically would need to do, so let me go ahead and undo all of this crossing off. Oops, sorry. So we found 30 and 14, right? So let me go ahead and undo all of this stuff, right? Let me pull up the eraser. Okay, so now we know that the median is 30, right? So median is 30 right here, right? So now what we want to do is find this, the middle of this right here, right? So we would have to redo the median method right here again. And then we get the middle of 20 and 26, right? So that is 23. Because we have an odd number of pieces, so we have to find the average. So this would be 34, right? So calculating it the same way we found the median over here. Does that make sense?
Yeah.
Okay.
I think she accidentally left the meeting.
Yeah, I think so too. Teacher, are you there? Hello?
My bad, sorry. I don't know what happened. Okay, so let me go ahead and open up the slide deck again. That's my bad. I don't know what happened. This tab accidentally closed. So
How long is this chapter?
we have a couple more slides left. So we have like, I think I'm gonna take like 10 more minutes and then we'll end up class. So yeah, that should be about it. Okay, so the shapes of box and whisker plots. So remember we went over skewed left, symmetric, and skewed right, right? So look at how the boxes are. So when the box is skewed to the left, right? The box is skewed to the right, sorry. That makes that the data is skewed left, right? So the left whisker is longer than the right. So most of the data will be on the right. So this symmetric, the box is right in the middle. So the whiskers are about the same length. Oh, and by whiskers, we mean this data right here. This is a whisker, this line, from least value to the quartile 1, and then the greatest value to quartile 3. Those are what we call the whiskers, by the way.
I don't get what the box stands for. Like, we learned how to do the first quartile and third quartile stuff yesterday. But I don't get what the box stands for.
I'll be going over in a coming slide, so just be patient a little bit. But just remember that the data is skewed right and left based on the box, right? So let's go ahead and I'm gonna move on. So to kind of like wrap up your question, I'm saying that we're gonna cover this like in a slide or like the next slide. So just keep waiting.
Okay.
Okay, so now your box. So look at your whiskers are all dependent on, you're skewing your data right and left is dependent on how long your whiskers are. So your left whisker is longer than the right whisker. And so that's how you know that the data is skewed left. Right, and so here the whiskers are about the same length. Skewed right is when the right whisker is longer than the left whisker. So then most of the data is on the left. Okay, so to kind of understand a better idea of what these graphs would do is to understand how this data works, right? So the fraction of the students that have at least a BMI of 22, right? So 22 is right here, right? So what this data does, it divides our group of people into it divides our group of people into a certain category, right? So you have the people that are average, right? So average is 21, right? The median of people is 21, right? This is the middle of the graph, right? The middle of the distribution of the graph, right? And this is the highest range, right? And this is the lowest range. And then 17 through 19. So that's the range, right? So the right whisker is longer than the left whisker. So is the data more spread out in the first quartile or the third quartile, right? So this is asking which way is the data skewed, right? So that's how you would answer this question. Determine and interpret the interquartile range of the data. So interquartile range is the third quartile subtracted by the first quartile, right? So the middle half of the student's BMI varies by no more than 3. So interquartile range is the difference between this value to this value, right? So a median of, so like middle of the half of the students, right? The middle half of the students would fit under this box.
I should also do that. So now
Make a whisker and box plot for each set of data. So you want to go ahead and try doing that problem. Let me know once you guys are done, okay?
What do we do after?
I can go ahead and show you the answers.
Okay.
Okay, so number 1. Is that what you got?
Yes.
Perfect. Number 2.
Yes.
Perfect. Okay, so Tanmay, are you done?
I don't really get it.
Which part do you not understand?
Like, I don't really get the box stuff.
So the box basically allows us to see where the middle of the group is, right? So with using the box, right? So when we go back to the box, this box right here basically tells us that the majority of people are in this box, right? This is the middle of the graph, and the majority of the people are in this box, right? Does that make a little more sense?
I understood it.
Like the median? Like
Not
median
exactly
or
the median, but like the majority of the people that lie there. Like in this scenario, right? Like the middle of so the BMI for 6th grade students, right, was 21, right? But the majority of students fell under the range between 19 to 22 students, right? And then there were some people like the odd case, like the really least amount someone had was 17, and the highest that someone had was 28. So the majority of the students that fell in the graph were here. Does that make more sense?
Yeah, it makes a lot more sense.
Okay, so did you try this problem out?
No, I'm still trying it out though.
I can go ahead and share the slide deck with you on Google Classroom if you want. So I can go over the problem with you. So yeah. So go ahead and just try to do it on your own, and then I can go over it with you.
After the class, can you send the slides so we could work on it a little bit more on the topics that were a little bit weak on?
Yeah, sure. Also, Khan Academy is a really good resource if you guys want to practice at any time. So, there you can search topic by topic. So I know that they teach box and whisker plots on there. So if you think that you don't know it that well, so that's a good way to test how much you know.
Okay.
Okay, so do you want me to move on or do you want to try doing these?
Oh, okay. I'll ask my sister a little after the class because she took AP statistics.
Okay, sure. Okay, so describe the shape of each distribution. So you see the distribution right here. Now try to determine which way that this is going to be skewed. Skewed right or left? It's definitely not symmetric because the whiskers are different shapes. So,
It's your left.
yep. Oh, you have to do the questions. Okay. It's fine. You guys determined that it was skewed left, so I don't think I need to go over these again. Okay, so I think that's all I have for today. But if you guys want to stop by, I can help for like a couple more minutes before I have to leave.
Are you going to send the slides?
Yeah, I'll put it on Google Classroom.
Okay.
Okay, thanks. Hope
How
you
about
guys.
homework?
Homework. I don't know who's gonna be posting homework. I covered all the slide deck, but I'll see if Prajna wants to give you any homework, and then we can see. You guys can do your homework then. So she may or may not give you homework. I'm not completely sure.
I don't think she's gonna give us homework because last week she forgot to post it on the same day that we had the slides. So she posted it a little bit later.
Yeah, but if she does post it, there will probably be it will probably just be like a review assignment to see whatever you guys learned in class today. So
Okay,
Oh,
thanks.
okay. Thanks.
no problem. See you guys. I'm not gonna see you guys, but yeah. So I hope you understood everything, and if I went a little too fast, I'm sorry. So yeah, thank you guys. Yeah. I'm gonna
Bye.
leave the call.
Okay, thank you.
No problem. Bye.